Before I do, I promise you I'll bring the books that I mentioned to class. So this is as close as it comes to a class textbook. We don't really have a textbook, but many of your readings, those that I say you really should do and those that I say you might want to do, are from this book. I love this one. This is the Bell, Clear, and Witten. This is about text compression. It's a little bit about information theory, but specifically as applied to language and text. Has a very nice discussion of estimating the entropy of natural language. And a lot of what I'm going to talk about now, today, comes straight out of here. This is the modestly titled All of Statistics book by my buddy Larry Wasserman, who's a professor of statistics here. And I think I mentioned that after he wrote this book, 2 years later he changed his mind and said, well, maybe that's not all of statistics. And he wrote another book called All of Non-Parametric Statistics. So this is really all of parametric statistics. I'm sorry?
It's not correct either. It lacks permutation test.
Okay, so he needs to write another book. I don't know what color he'll choose for the other one. This is a wonderful, this is by Maurice de Groot, the guy who used to be the head of the statistics department here, the very first head. He's no longer alive, but it's a wonderful book, a great reference book to all things probability and statistics. This is specific statistical methodology for speech technologies, for speech recognition. So this is a very specialized book. And there are many other good books. These are the ones I happen to have and know. Okay, so we're talking about the source channel paradigm, where we're using thick chalk, or I think thin is good enough, right? If it's not, let me know. We use several examples. The task, which way I'm going to do it? I'll do it this way. This is the task, was speech recognition. Which means the mapping that the task has to do was from an acoustic signal to a sentence, which is in a language domain, to a piece of language. The source channel paradigm would flip this relationship and would think about it, the source channel thinking model would be to say that once there was a language source and it spews out sources of language, and any piece of language that comes out goes through a channel that maps language to acoustics. Notice the order here is reversed. This is our original task was to map an A to an L. The story we tell is that an L gets mapped to an A. And out comes an acoustics. And then the base classifier that comes out of this thinking says that the language that we should choose, the piece of language we should choose, should be the one that maximizes over all possible pieces of language the posterior of that language given the evidence that we have, which is the acoustics. And this boils down to argmax over L of P of L times P of A given P of A given L. I'm just repeating what we did last time. And now we broke the problem into two modeling problems. One is modeling language. So I'll write that here. PL, model language. And P of A given L, model the process of how a language gets mapped into acoustics. So we're modeling the L to A process. Now the same idea is now applied to another task, machine translation. The machine translation task takes English and converts it into French, say. Of course, any two languages will do. The source channel model flips that and says once there was a source of French, it passed through a French to English channel, and out came English. And therefore, the Bayes classifier is give me the French that argmaxes over all possible French sentences, and I'll go directly to the final product. Probability of French times probability of English given French. Again, this would be the prior over French sentences, and this would be going off with a separate research group and studying how French sentences get mapped into English sentences. And you pointed out correctly that in this particular case, if we can build a decent model for this, so remember this is going to be a model, so hat means it's an estimate rather than the true probability. If we can build a decent estimate for P of E given F, why can't we just build a decent estimate for P of F given E and plug it right here? Because this is proportional to P of F given E. And we argued about why we might want to do that. One of the reasons is that we're free to estimate this using lots of monolingual corpora. Whereas here, we are restricted to using bilingual corpora that are aligned, and there are far fewer of those. I want to do one more example and add it to this list. So the example I will do it's always in an obvious place. Here it is. The example I want to do is topic detection or topic classification. So call it topic classification. So the problem is you have a document and you want to map it into a particular topic from a set of topics. So T will stand for topics. So then you might have 5 or 6 or 10 or 20 topics. Let's say you have an article in the newspaper and the topics might be sports, military, financial news, politics, what have you, science and technology. And we'll assume for simplicity that every article has a clear mapping to one or the other. We just want to know which one. This turned out to be actually a fairly simple, fairly easy problem. We know how to do that very well. So the first thing you do in the source channel model is you reverse the relationship. You say, suppose there was a topic, or rather there was a source of topics, and from that source one topic came out, and it went into a channel that converted a topic into a document. And then out came a document. Well, what does that mean? I mean, these source channel things are a little funny, but actually this makes sense. Because if you think about the process of how documents are created, some writer decides, I'm going to write about sports. And then, conditioned on the fact that they're writing about sports, conditioned on the topic, they write something. Right? And in fact, you can think about it as an even more refined process. First, they decide to write about sports. Conditioned on that, they decide to write about baseball. Conditioned on that, they decide to write about a particular baseball game. And then out come the words from that specific topic. But in the simplest method, they choose from one of 6 or 10 topics. So let's say they chose sport. And then they choose words, and they're likely to choose words that have to do with sports. Right? They're likely to use words like ball and referee and score, and as opposed to words having to do with science, so forth. But thinking about it in this framework allows us to write the Bayes classifier right away as the winning topic would be the one that maximizes over all possible topics the posterior of the topic given the document, which, as usual, I can write first as probability of the prior of the topic times the probability of the document given topic divided by the probability of the document. This is over all topics. And then I notice, as I did in the other cases, that the document does not participate in the maximization. So it's a constant with regard to the maximization, so I can cross it out. So I'm left with just these two, just like here, just like there. One difference is here I searched in principle in the space of all possible sentences, which is a very large space. I cannot expect to explicitly enumerate it. So I have a serious search problem. Here I search in the space of all possible French sentences. Again, it's an exponential space. I cannot expect to explicitly enumerate it. I have to come up with a clever search mechanism. Here I'm doing maximization over a space of 6 or 10 possible values. So I can actually literally explicitly try each one of these values. So that's one thing in our favor here. The other thing is that we now know that we need to estimate both of these things. So I'll put heads on them to say I need my best estimate of a prior over the topic and my best estimate of the distribution of documents under any given topic. So first for the prior over topics. This is a prior over topics. That's actually quite easy. Because there are only 6 to 10 topics, I don't need too many labeled examples to estimate them properly. If I had 1,000 newspaper articles all labeled with the correct topic, sports, politics, sports, science, whatever, you can imagine that some simple relative frequency would give me a reasonable estimate. This one 20%, this one 10%, this one 5%. So this is easy. It's easy because the number of parameters is small. You know, there's order of 10 parameters. So a small amount of data would be enough to estimate it. This guy, given the topic, is a little harder. But what this is, it's really a language model. One language model for each topic. Create, this is a head, language model for sports. Create another language model for science. Another language model for politics, and so forth. So I need 6 to 10 language models and a simple estimation of 6 to 10 parameters of their prior, and I'm done. So the same framework, sometimes very easy, as in the case of topic classification, sometimes very hard, sometimes involves significant search and has to be heuristic search because the space is too large. Sometimes it corresponds to a process that we believe is really the process that generated the data. I would say that's the case in the case of speech recognition. I really do believe that this somehow generated that. And I do believe the topic somehow generated the document, kind of. Sometimes it's a silly mental exercise to say that I see English and it used to be French when it was little and it got converted. But the same process can be applied to just about any language technology you can think of. So optical character recognition, spelling correction, question answering, information retrieval. And in fact, when this was first formulated formally, it was first done for speech recognition in the 80s, worked very well. And then they said, well, why not apply it to machine translation? So in the late 80s, early 90s, it was first applied to machine translation. And that worked quite well, although not as well as the prevailing method for a while. And then a few years later, they started applying it to information retrieval. And now it's sort of standard practice. The first thing you think of when you have a new language technology problem is, let's try the source channel method. The terminology source channel came from information theory. So it's Claude Shannon, the guy who invented information theory in the late 40s, early 50s, who came up with this notion of imagine you have a source that transmits bits, and imagine these bits go through a noisy channel, so sometimes they get corrupt, and so forth. Questions? Comments? Please. What would be the parameter for a topic language model? So we talked last time about language model in general, right? We didn't say how we're going to estimate it, but we said that we need, one of our goals is to estimate the probability of any surface sentence without annotating it. So the parameters would be the same. They would just be different values for the different topics. I realize I didn't answer your question because we're going to spend a lot of time about building a generic language model. But the only answer I'm giving is whatever you would use for a generic language model of English, you would build 6 to 10 separate ones with different tweaking of the parameters for each of the topics. As you can imagine, it would depend on the particular words and the order in which they occur. In fact, this is a great segue to talk about the heterogeneity of language. So we talked about English until now as if it were just one thing. I think I told you at the beginning of the last lecture that we're going to pretend that language is a source or distribution, that you push a button and you get out a sentence. In the real world, of course, language is never uniform. Not only are different languages different, but there is no single English. There's the English you find in newspapers. There's the English you find on the web. There's the English you talk to your friends with. There's the English you talk to your children with. There are many genres, many kinds of written English. So I'd like, with your help, to make a list of at least some of the dimensions along which language varies. Okay, you'll be amazed at how many different dimensions there are. So we will call it sources of heterogeneity. In language. So give me one dimension. Yeah.
Maybe
Audience.
audience.
Okay. So who you aim your language at changes how you speak or how you write. Yes, go ahead.
Which time it was written or spoken and
Yes. Time. So time of creation or creation time. Creation time. So what do you have in mind? Can you give me an example? In what? I'm sorry? Right. So what you have in mind is over a span of hundreds of years. And clearly there's modern English, there's what is it called? Early English? Old English, early modern, there's variations. So that's over a period of centuries. But if you ever looked at English that was written 100 years ago, or even 50 years ago, you can tell it's dated. I mean, many newspapers like to publish features from 50 years before and 25 years before. And I don't know about the 25 years before. Maybe you can tell. I can't always tell. But things that are 50 years before, I could definitely tell, not just from what they're discussing. Just the language is different. So there are changes also over a period of decades. Go ahead.
in scientific papers, when you look at older scientific papers, the style of writing varies considerably over.
Even within scientific writing, the style of writing is quite different. So that brings up scientific writing. So I'll summarize that with genres. So genre could be scientific, it could be legal.
Some sense, kind of, isn't it a part of audience, genre, the formality of the situation in which you're communicating language with? Doesn't it all boil down to the audience to which you're catering to, in a certain sense?
I can see the relationship between the two, but I can also think about them as as separate in the sense of genre could be, is it fiction or non-fiction? That's a genre, and you could argue that you could apply them both to the same audience. Well, could argue either way. Oh, I like that a lot. So that's a completely different dimension. Written versus spoken. Very different language. Written versus spoken. Which language do you think uses a bigger vocabulary? Written or spoken? Written. Much bigger. Much bigger. Maybe because we have time to think, maybe because we're expected to be more accurate and more erudite. When was the last time you used the word erudite in conversation? What about length of utterances? I would say sentences, but it's not clear that there is such a thing as a sentence in spoken language. But to the extent that you can map, and to the extent that you can put periods at the end of things that I say, like right now, what do you think is the relationship between the average length of a spoken sentence and average length of a written sentence? One person loud instead of 20 people mumbling. Which one? Written sentence is longer. Yeah. Yeah, written sentence is longer. Again, it's kind of problematic. What do you call a sentence? Because we don't talk in sentences. We talk in agrammatical fragments. Oh, we'll talk about that.
So syntax is different between speaking and writing.
Right, right. I'm not writing on the board because I'm listing all the sources of differences, not how the differences manifest themselves. But I agree with you. It changes the syntax, changes the length, it changes the vocabulary size, effective vocabulary size. Under genre, you can fit lots of things. You can fit poetry. You can fit not topics, so I can have topics separately. But I jumped ahead. Time, it could be centuries. It could also be decades. But it could also be much smaller time frames than that in some genres. So in the genre of news, the news you see today is not the same news you saw a month ago. Right? An event happens, and all of a sudden it's in the news for a long time. Some events are in the news for a long time. Some events are in the news for a short time. Things go in and out. In fact, when you deal with web sources that are constantly updated, the distribution there changes by the minute. So it could be all the way down to minutes. Okay, so that's time, audience, genre, written versus spoken, topic. Can you think of others? Yeah. Go ahead. Location of the producer of the language?
Indian English.
Ah, that's great. So I would call it dialect. I'm sorry? Partly, but you may not be able to. I mean, if you grew up in a certain area, and if you grew up in the U.S. and you're speaking to a UK audience, you may still speak American English. I mean, knowing who your audience is might affect what you say or how you say it, but you have certain limitations. I mean, we make, I make mistakes in translating from my native language to English, and so I don't know if you would call that a dialect, but yeah, it always amazes me when Americans look at Indian English with dismay as if it's wrong English until they realize that there are more speakers of Indian English in the world than of American English. I don't know if that's completely correct, but it's certainly comparable. And of course, the British hold their nose up at American English because the British have the right English, right? But no, they don't. So in some countries, let's talk for a moment about descriptive linguistics versus prescriptive linguistics. I was growing up in Israel. I was taught the correct way to speak Hebrew, and there's actually an academy that decides what is correct. That is also true in France, right? There's a French academy that decides. So these are countries that really have a lot of pride in their language, and they They are very worried about it and they want to, legislate it. America, I found a lot looser. There are lots of different kinds of English here. The prescriptive linguistics is the linguistics that tells you how you ought to speak. Descriptive linguistics is the linguistics that just describes to you how people speak. And most people ignore how they ought to speak and just speak how they want. So descriptive is really more of a science. Prescriptive is more of an ideology. How did I get to that topic? Oh yeah, the British and the correct English. So I don't know if it's correct or not. Language is used to tell social classes apart. Certainly clearly in the UK, but in every other country too. The rules might be different in different countries, but it's often used. Language and also pronunciation are used to tell. So I don't know if I should add, well, I need another board. I made a mistake. I started writing on the top one. I should have started writing on the one further in the back. All right, can you think of other age of the speaker? Okay.
Education level of the speaker.
I like education level better, but I'll accept age. Education level. What do you think about gender? Is there a difference between the way men and women produce language, either spoken or written? I would think there is. Yeah. I don't know exactly how to characterize it, but I would think there is. There is so much language around, there's so much data, that just about any factor you can find some differences if you look deep enough with enough data. The question is it significant difference? Is it meaningful?
Depends a little bit on the language.
I'm sorry?
Depends a little bit on the language. Some languages, there are like actually syntactic differences. Like
Right. Right.
women's language is supposed to have like different patterns.
I should know that. My native language of Hebrew, there is a gender-dependent conjugation of verbs for the first person. So if you say, I know, you'll say differently if you're a man or if you're a woman. And of course, there's different conjugation for second person and third person as well.
There are even some languages, like I think the examples that were from the Amazon, where men use certain phonemes and women use certain phonemes, and they don't completely overlap.
Wow, I have not heard of that. That is very cool.
Political background or worldview?
So, yeah, worldview. I'll just make it worldview in general. So people use different, choose different terms, terrorist or freedom fighter, right?
Format, so tweet versus blog post.
Yes, I like that a lot. So I don't know what to call it, but it's, I'll give the examples first. It's used to be that people wrote letters or newspaper articles, and then they started writing email, and that changed their choice of words and syntax and how much care they put into it, and then they started writing tweets, and then they started writing text, and there was a gradual move towards less care, one-off, as opposed to check your, right? The easier it is to write and the more you do it, the less you pay attention to it, and now there are all these, so these are tweets and SMS. I don't know what to call it. Do you have a suggestion for a name for that phenomena? Medium? Okay. I used genre for something else, although it's a reasonable choice for medium is, yeah, that's good. Medium is a good choice.
Style like conventional poets and images poets, and they are writing the same
Okay.
style, but
Writing style. There is actually a difference in speaking style as well. Some people who studied fluency in spoken language discovered that people pretty much fall into two different categories. When you speak, you kind of improvise on the spot, and some people start talking and then change their mind, and they kind of stop themselves in the middle and then correct themselves and continue. And other people are more what's the word for it? Conservative. What I mean is that they think through what they have to say and then they say it. So there are repeaters and there are deleters. Those are, I'm sorry? More contemplative, perhaps. So there's the way you fill the pauses, you fill the time when you're thinking what to say. Do you fill it by going ahead and then correcting yourself? Or do you fill it by repeating the last thing you said? People tend to fall into this or that. Sometimes people use pauses that are, they fill them not with language but with sounds, like That varies from language to language. So in Hebrew it's eh. In German, I think it's eh, native speaker of German here. In English, it's or ah. There are two of them. And I think they fulfill somewhat different semantic roles. Can you give me something from other languages? I would need to think hard before I could produce that.
In Japanese, they give it an actual part of speech type thing. That it's actually.
Yeah, there are words. The two words are ano and eto.
Yeah. Like, and it's actually
Uh-huh.
a study thing. It's not just like, oh, sometimes you say it's an actual like part of speech thing.
Well, it's filled pauses in English are studied too. The question is, do they change the semantics of what is said? And sometimes they do. I'm sure you can find examples when they do. Of course I remember you. You are Rose, right? That changed the semantics of what I just said. Sorry?
In Spanish they say
M. Okay.
There's this stand-up comedy sketch which says that in Chinese, I don't know, they actually have a filler word or something. It sounds like nega.
Right.
Okay.
It's nega. So yeah, it sometimes causes troubles in US.
Okay. I want to add one more before we move on, and that is register. So register is a term in linguistics that has to do with the social and contextual relationship between the speaker and the person they speak to, or writer maybe, but it's mostly for speech. So it captures things like, are you talking to someone who's below you, like a child, parent to a child, someone who's your peer, like your brother, your colleague, your friend, someone who's above you, like a parent or an elderly person, or a VIP. In some languages, there are distinct rules about how you speak to them. So the word for second person, you, would be split depending on if you're looking up or you're looking straight, right? That's true in French, in Spanish, in Chinese, right? Right. My mother spoke Polish to her father, and in Polish, the way you address your father is by saying the father. So it's a third person. So that many languages use term of respect, use third person, not second person, even if you're talking to the person. So she would ask him, does the father want some tea? And I used to laugh out loud when I was a kid. When I didn't speak Polish, but that much I understood. So to me, going up in a language that's exactly the opposite, it does not pay respect to anybody. It was a very funny way to think about it.
Is it just the father or the mother?
Oh, the mother too, absolutely. Anybody who's in position of authority, it's like, would the queen like me to do this? You don't call them you to their face. You don't use second person to someone of higher esteem. Any other languages that do that?
I just have an interesting
Uh-huh,
fact.
please.
So in Polish, it's like when you talk to somebody who's older than you, who you want to respect, you use the third person.
Right.
In Hindi, not now, but when I was a kid, I used to read some things from like maybe, so my like grandparents, like they had some books and also sometimes I used to read those. So like if there is a description about some person, if you want to respect them, so you start talking about that person in third person, but since you want to respect, you start using you form. It goes the other way around.
Interesting. Interesting. I did not know that.
Also in Persian, when you want to be polite,
Uh-huh.
you use the second person plural. Yeah.
Right. And Spanish as well, and French as well. Not in Spanish. Usted?
Spanish, the formal is usted.
Uh-huh.
Comes from Western usted.
Okay, but isn't it the case that second person plural is the same as second person respectful, singular?
No, it's third person singular is second person respected.
Yeah, you do usted for a single person formal,
Uh-huh.
or ustedes for plural.
Oh, ustedes. Okay.
And ustedes is also fine.
In Latin America, they don't use the second person plural informal.
Yeah, in Latin America.
Okay. So I learned my Spanish from Mexican Spanish, and that's why I get
And in the
confused.
plural, there's no formality distinction, but in the singular there is.
Okay. One more thing, in Arabic, that's not having to do with respect, but I don't know what it has to do with, but in many structures, linguistic structures, male is single, and masculine is single, and feminine is the same as plural. So the feminine form is the plural form. Anybody who's a native speaker of Arabic or knows some Arabic? You want to correct me, contradict me, or add anything to that?
No, I don't know about that.
Well, if you don't know about that, I'm in trouble. You don't know of cases where the plural is the same as the feminine?
I know of cases where the plural is inclusive, where the masculine plural is inclusive of the feminine.
That's true in Hebrew as well. That's true in most Semitic languages. But I'm talking about where the plural form of a masculine happens to be identical to the feminine form. All right, I'll bring you examples. I'm mildly embarrassed that I can't come up with them on the spot, but I will bring you examples. Okay, the reason I went through this trouble of making this whole list, and I'm sure it's not complete, I'm sure there's more, is because you have an assignment to choose one of these and to find, I mean, it's all written up on the webpage, so you don't need to write down anything now. But one of the things you need to do in your assignment is to find two corpora and to find some differences between them. And ideally, the best would be if you could choose something that differs only along one of these dimensions. So everything is the same, except this is by a man, this is by a woman, or this is spoken to children, this is spoken to adults, or this is written, this is spoken, or any one of these dimensions. In practice, it'll be hard to do. So you might mix and match. You might find two corpora that are different along more dimensions and figure them out. So you'll need to come up with some hypothesis, what you think the differences are, and then measure it and see what happens. One of the simplest things we can do in comparing these different genres and sub-languages is look at the distribution of words. So when we say words, I start talking about words, I should define the word word. And it turns out the word word is used loosely to mean two very different things. So I want to set it straight. One of them is a word token, or start word type, and word token. So we all know what these mean, we just don't know that we know what these mean. So when people say to you, I read an article, it consists of 385 words, it was 385 words long. These are word tokens. Many of them were repeating themselves, like the word "the" occurred many times there. So when they say there were only 270 different words in there, what they mean is word types. So word type refers to the type of the word as it is listed in the dictionary. Okay? When you hear the word type, think of a dictionary. Token, when you hear the word token, think about an occurrence of a word in running text. Actual occurrence. So once we standardize our terminology, it makes it much easier to talk about how many words and what words and all of that. So whenever I use the word word, please make sure you understand if I mean word type or word token. I will try to always say word type or word token. Sometimes I'll forget, sometimes it'll be very obvious from the context, but if it's not clear, ask me if I mean type or token. So one of the very first things you can do, before that, let me ask you, how many word types are there in English, do you think? Thank you. That's the right answer. I mean, it really depends on how you define it, because do you include singulars and plurals as two different types? What about apostrophe S? In highly conjugated languages, like French or Hebrew or Arabic, do you include any variation of first person, plural, singular? I'm sorry? or agglutinative languages, or German, where you take any two nouns, put them together, whoops, you got another noun. I'm sorry? Which English? Yeah, so it's not well defined. But give me an order of magnitude. Hundreds of thousands. Yeah, it's about right. Several 100,000. It depends. Right, it depends. It depends on a lot of things. But some languages have more words than others. Certainly German, if you consider every noun phrase. So German has this quaint property that noun phrases don't necessarily have to have spaces in between them. So in English you have a train and you have a train station, and you have a train station headmaster. In German you have a train station together, and a train station headmaster, one word. Okay? You might argue it's not a word, but if you use definition of spaces, it is a word. So it's really an unlimited number of nouns. Now, how does the number of tokens in a text refer to the number of types? So one of the simplest thing you can do in a language is build what we call a type token curve. Along the x-axis you'd have the tokens. So these are the running words in a text. And along the y-axis you might encode the number of types that were encountered so far. So the first word you see of the text clearly is a new word. So you go to the right one and up one. The second word you see in the text, chances are, is different than the first word. So you go right and up. And you keep going right and up and right and up in a 45-degree angle until you hit your first repetition, the first word that repeats itself. At that point, you move a little bit to the right, but you don't move up because you didn't increase the number of types. You just increased the number of tokens. And you keep going up, and then you hit another repetition. You keep going up, you hit another repetition. And with time, you'll hit more and more repetitions, right? After you saw a very large chunk of text, most words that you're going to see are going to be repetitions. They're not going to be new words. So for most words, you will move horizontally, but not vertically. And occasionally, you'll move vertically when you encounter a new word type. So if you zoom out and look at it from far away, this would look like a 45-degree line that starts curving down. It never really reaches horizontal, because complete horizontal means that you don't see any new words, and that does not happen in natural language. But now you can compare two sublanguages along this type token curve. So let me show you some examples. Oh, I can control it from here. So the three sublanguages I will show you are all written languages. They're all modern, from the 1990s. Two of them are newspaper, so they share a lot, the newspaper articles, from two different newspapers. And one, I'm sorry, I misspoke. One of them is actually spoken. So I'll talk about them a little bit. Let me first show them to you. How do I change the light? I think I have to do it here. Nope. Okay. So these are 3 type token curves. I'll start with the, say, the dotted one, this dotted one. This is the Wall Street Journal. So these are Wall Street Journal articles from the late 80s, early 90s. And I only collected about 1 million of them. Or, no, I'm sorry, it's this one. No, it's this one. It's the richer one. So I actually had a lot more than 1 million. I just plotted 1 million of them. And I'd like you to compare it to the broadcast news, which is this one. So broadcast news, I have to tell you what that genre is. We worked a lot with it when we did speech recognition. It's news programs that were recorded over mostly television, some radio, and transcribed. And it's a very strange genre because on one hand it's spoken, on the other hand it's not completely spontaneous. News anchors often read from a teleprompter or from prepared notes, and it wasn't just news anchoring, it was also news articles. So it would be a news anchor introducing a story, then switching to somebody in the field who was interviewing someone, then switching back. So it had some elements of spontaneity, but it also had elements of prepared text. You can see that Wall Street Journal is a richer language. Okay, that reflects the fact that broadcast news is somewhere between written and spoken. Compare that to telephone conversations. So these telephone conversations, I should tell you a little bit about them. They come from a very famous corpus called the Switchboard corpus. How many of you have heard of Switchboard before? Okay, quite a few. Switchboard was collected in the 80s and 90s. It's a collection of telephone conversations between people who don't know each other about a topic they don't care about. Let me explain. The way it was collected was several hundred people volunteered or were paid actually to be part of the study. They were distributed all over the US. And an automated system paired them at a specific time, called 2 people at random, connected them, and introduced a topic. And the topic was one of 70 pre-selected topics. The topic could be, what do you usually wear to work, or childcare situation these days, or the status of the economy, or some topic. And then people were asked to talk. And of course, in the beginning, since they don't know each other and they don't really care about the topic, they kind of and ah. But soon enough, it's like start small talk. And a minute into it, you start recording, and they record for 5 minutes. The idea is to just, I don't know why the US government would want to listen to conversations between people, but for whatever reason, they wanted to see how you can do that. So this corpus had interesting characteristics, because one thing we didn't list on our list of differences is whether you know the person you're talking to or not. A few years later, they collected another corpus called Call Home, which had similar characteristics, except you called your family back wherever you were from. So now you talk to people that you know. In terms of it's much, much harder to recognize speech when you talk to people you know, because you talk much faster, less clearly, with many more abbreviations. You drop consonants. You use all sorts of clues that are common to both of you. It's like you're creating your own code, your own language. Anyway, this is Switchboard. About 3 million words worth were collected and transcribed. And you see the huge difference between a fully spoken language, fully spontaneous language, and a fully written language. So you see after 1 million tokens, the conversational language reached only about 15,000 word types, whereas the spoken language reached double that. Fair enough. You're right. That was a confounding factor. I still believe that the choice of vocabulary is much narrower for spoken language, and I'll show you another piece of evidence for that.
Is there any difference when you look at a corpus where
Mhm.
If I don't know someone, I don't know if they're educated, I don't know if they're going to understand a big
Right.
word I'm using, like, or even English is their first language.
Right.
I'm probably going to talk down to them a little bit. Is there a difference in these sort of ones? In that
Right. I would think there would be. It just gave me an idea for how to solve your homework if I were in your place. Wikipedia has English and simplified English, right? Some of you thought of it already. Okay. So let me give you the other piece of evidence. And that comes from what I call the head and tail lists. So the head and tail list is simply take a corpus, count all the word types and how many times they occurred, and create a word frequency list, a sorted word frequency list. Now, so the most common word is at the top, and you see how many times it occurred, and the next most common word, and so forth. And that creates a rapidly decaying list of words with their frequencies. And then show me just the top of it, the head of it, and the tail of it. So let me give you the head and tail for these three genres. It would be here, so let me. Okay. So this is the Wall Street Journal. I took a million word tokens, and not surprisingly, the word "the" is the most common word. The word "there" is almost always the most common word. Its frequency in written newspaper articles is about 5%, so it occurred about 50,000 times out of a million. We will see in some other places the frequency changes a little bit. The second word is not a real word. It's the end of sentence symbol. You can think about it as a period. So the fact that "the" is more popular than the sentence separator implies that on average there's more than one "the" per sentence. Right? In fact, we know how many. 49,000 over 42, so it's 1.2 "the" on average per sentence in Wall Street Journal.
It also tells us the length of the sentence, right? Because
It does.
if you're saying about 5%, that'd be like
It does.
25 words.
25 words, exactly. Wall Street Journal.
What's the difference between all capitalized and not?
So everything is supposed to be capitalized. The only thing that's not capitalized there is the end of sentence symbol. Point and percent. The symbols, yeah. So there are, oh, you're right, the percent, so there are symbols, thank you. So there are actually lots of little details that you need to decide when you do these things, like do you consider different cases the same or not? And the answer depends on what you're going to use it for. And the end of sentence? Well, I just considered it a sentence separator. So it's the end of a sentence and beginning of a new sentence. There are lots of little decisions that you have to make, and they might change some of the picture. Yeah, the average sentence length in the Wall Street Journal is 25 words. Do you want to guess what the average sentence length is in USA Today? Less than 15. It will be interesting to draw USA Today versus Wall Street Journal type token curve too. So another idea for your homework. What else can I tell you about it? So it's not very surprising. You can kind of see the beginning is very familiar. It's the, to, of. You go a little bit further down and you start finding hints that this is a financial newspaper. For example, the point comes from all the numbers. So the Dow Jones average went up 3.5%. So that's the point. Here we have dollars, so we know what Wall Street Journal is all about. It's about dollars. And lots of numbers feature here. If you go to other newspapers, the very top will remain the same, but these specialized words might be further down. Look at a million. Look how many times million is there. Okay, and here's the tail. The tail consists of words that occurred only once. And of course, this is a very small subset of the words that occurred only once. I just took the very bottom of the alphabetically sorted, well, it's not even the bottom, just a section of the alphabetically sorted list, those who start with Z. What I like about the bottom is that it usually tells you things about your processing, how you process the data. It gives you clues what kind of mistakes you made. You may find many spelling errors among the singletons, the words that occurred only once. You will not find, there's a word in English, a very common word, that you will not find there. Have you seen that word? I'm sure you have. I'm sorry. One of the most common words in English. And the reason is you start from a very common word and you make a very common spelling transposition. So this is unfailingly in any text that was not generated by Microsoft Word, with spelling correction, you will find a lot of that word in it. So you find things like that here. You find things like punctuations of different types. This was processed, cleaned very nicely, so you don't find anything here. But if you just do your first processing of a corpus, I advise you to look at the bottom, and you'll find interesting things. Let's compare it to the head tail for the other genres. So here is broadcast news. In broadcast news, the top is the sentence separator. Interestingly, the frequency of the is about the same. It's about 5%, right? It's 48.9, 4.89 as opposed to 4.9 something. Very, very similar. So the frequency of the didn't change, but the frequency of sentence separators, namely the average length of a sentence, did go down considerably. The first clue that this is conversational language, other than the sentence length, I find here. You and I. You and I are going to be way down in Wall Street Journal. They'll appear mostly in quotes. And there are other words. I don't know about have. All right. Let's look at conversational language. Now I rules supreme. I don't know what it says about us as human beings, but come on. I'm sorry? Zoom in, yes. It would be just here. Why is that? There we go. No, I was looking for that button, but okay. So I is the most common word, and here's you, and here's okay. If you consider it a word, then here it is. It was transcribed with and there's aha. That's different. But they are some of the most common words. But if you exclude those, you have the usual the, a, to. Of is further down. In written language, of is right after the. And noise. So these are all artifacts of the specific things you chose to transcribe. You would think that transcription is a well-defined task, but it's not. You need to have usually a huge, thick manual how to transcribe, what acoustic events to write down and how to write them down. In this case, we were interested in noise, not just noise, but what kind of noise. Door slamming, or lip smacking, or microphone falling, or interested in repetitions, in partial words, in filled pauses, and so forth. Okay, what's common to all of these is the fast dropping frequency list. So the most common words are very frequent, and then as the word rank goes down or goes up, as you go from rank 1 to rank 2, 3, 4, 5, the frequency of the word goes down. And if you looked at the entire list, it goes down very fast and then slows down. So this phenomena goes by the name Zipf's law. One way of defining Zipf's law is in terms of the probability of a word as a function of its rank. Where did I put the eraser? Come on, you guys. Where's my eraser? I know I put it somewhere. Zipf's law relates the rank of a word. So rank is it the first in the word frequency list, or second, or third, and fourth, to its probability. So the probability of a word is roughly proportional to 1 over the rank of that word. That's an empirical law. It means that if you draw the rank here, so 1 is the, and 2 is, say, of, and whatever the rank is in your particular corpus, and here you draw what he calls the probability, but is actually the relative frequency of the word in that corpus, you will get something that looks like this, like 1 over x, like y equals 1 over x. Is it true? The answer is yes, it is true. Here's an example of rank versus frequency from a corpus. I think that may be the Brown corpus. So it's amazingly close to, theoretically correct. Of course, it's not exactly true. Because this is proportional, we can calculate what the proportionality constant is. We'll call it mu. So this would be mu, and now we don't have to write proportionality. We can write equal to mu over this. And mu, for English, for a generic kind of English, happens to be around 0.1. The other nice thing about this kind of inverse relationship is that if you draw it in log-log scale, it looks like a straight line. So the log probability of a word would be log mu, which is another constant, whatever it is, minus log of the rank of that word. So if I drew now log rank instead of rank and log probability instead of probability, I should get a straight line. So this is the x, right? This is the y, and this is some constant. So y equals some constant minus x. So it'll be a straight line at a 45-degree angle going down. And sure enough, here it is. Now, where does it deviate? It tends to deviate in two places. It deviates a little bit from the straight line here. This is around the most common words. Very small deviation. And it deviates more strongly here at the bottom. These are the words that occur so few times. Look, this is what they call the frequency, or the number of times they occurred in the corpus. This is 10 occurrences. This is 100 occurrences. So this is 1 occurrence, 2 occurrences, 3 occurrences, 4 occurrences. So the data is discretized at this level. These are the words that occurred once or twice. So clearly you cannot get a straight diagonal line. But you get something very close to it. Zipf came up with a sort of a theoretical explanation to why this holds not just for words and language, but in many, many areas. If you go to, if you look at any natural phenomena, like different of bugs in a number of bugs in a forest, you go into a forest and you collect insects and you classify them by their types and tokens. You know, how many insects of each species. Or if you look at the distribution of cities in the world or in any country in terms of its population size, there are a few that are very high population and there are many that are very low population, and if you draw rank by population, you'll get another Zipf distribution. So you find it in many, many places, and he came up with this metaphysical principle called the principle of least effort, or least, I don't even remember what it is. People who came after him showed that actually a lot of it can be derived if you assume that the process that generated data followed some very basic sort of Markov properties. So if you put a monkey in front of a typewriter, And that typewriter has a space bar. And you just have them type, and occasionally they hit a space bar. Under some very general conditions, the words that would come out would behave like Zipf's distribution, because it stems from the fact that there are fewer short words than there are long words. Right? There are only 26 different one-letter words that could exist in English, and only 26 squared two-letter words and so forth. So that explains most of it. Anyway, after Zipf came a mathematician called Mandelbrot, and slightly generalized Zipf's distribution to something that fits this data as well as other data. Now, where did I put it now? Here. Okay. If I only remember where I tend to put it. So Mandelbrot generalized the probability of a word starting with that mu over rank. First he said, let's make it rank to the power of some constant. And second, let's add some constant here. So that's the generalization. Zipf's distribution said that C is 0 and B is 1. But this is generalized along 2 dimensions. If you take that to the log base, you get log probability of a word is some constant, which is the log mu, some constant, minus B times log of C plus R. Now remember that R is the rank, that's our X, and that's our Y. So what we have here is some constant minus some other constant times the log of C plus R. Now, we can no longer think of log of R separately, but we can define X as this whole thing. So I don't know how to interpret this thing here, but I know that what this does, it changes the slope of the line. So what Mandelbrot allows you to do is to change the slope of the line. What this does, it changes the log transform itself. When the rank is very low, it still allows it to start from a relatively high log transform. The Zipf's law applies not just to individual words. It also applies to word pairs, word triplets, long-distance word correlations, and as I said, it applies not only in the domain of language. In fact, we can draw type token curves, not just for individual words, but for word pairs or word triplets. Let's do that. All right. So unigrams, we saw those. Oh, we didn't see that. All right. We saw this. So this is the type token curves for the 3 corpora. In the spirit of the Zipf's analysis, we can draw them in log-log scale. And what we get then is 2 lines that are almost completely parallel, but are shifted. Okay? To remind you, this is a comparison between telephone conversations and broadcast news, which is an almost written kind of genre. We can apply the same idea of type token curves and the log transform to bigrams. Okay, this is all 3. I'm sorry. You see all 3 here, and you see that they are pretty much parallel, except there's something funny happening at the very beginning. But the first 1,000 words, I don't know how reliable that is. It could be a particular document. All right, here are the bigrams I was looking for. 2 genres. What I collected here is bigram types versus bigram tokens. To make sure we know what we're talking about, a bigram is a consecutive occurrence of 2 words. So a bigram token, if you have a document of 1,000 words, how many bigram tokens are there in it? Well, assuming you go across sentences. Are they is what overlapping? They can be. So if you have 1,000 words in a document, you would have 999 bigram tokens, because you'll have a moving window of 2 moving across it. Okay? I didn't mean for it to be more complicated than that. I just want to make sure we knew what we mean by when we say bigram tokens. The number of bigram types would be significantly lower than that, because some bigrams will repeat themselves. The most common bigram in English is of the. But the repetition is not going to be as severe as it is with individual words. So as a result, the type token curve is not going to curve down as fast as it does for individual words. You can see here that you can barely see the curve, but it's coming. If you go to 100 million word tokens, you will see it curve down. After 100 million word tokens, the rate at which you see new bigram tokens or new bigram types is very, very low. So it's the same shape of the distribution, but it's stretched over a much longer. And even in the bigram type token distribution, you can see a big difference, maybe even a bigger difference between the two genres than you can see in the single word type token curves. And if you take that and put it in the log base, you get two lines that appear to be identical and then kind of split off here. Then you see the distance between them. Remember that anything below 1,000, well, this is 10,000 actually, so it's quite reliable. And we can go further and go to trigrams. So in trigrams, it looks almost like it's going in the beginning at the 45-degree angle, right? Because the repetition of 3 consecutive words is very rare in the beginning. But it's not rare for long. And just to give you a sense, after 40 million words of news articles, which is what I've worked with, the rate at which you see new trigrams is about 10%, 10-15%. So 90% of the time, the next trigram is something you've seen before. The rate at which you see new bigrams is much lower than that. It's in a small single percent. And put them in log-log scale, you don't see the difference. All of these statistics were collected a long time ago. I didn't bother updating them because there are much better statistics now on the web on much larger text corpora. So I want to show you, the last thing I want to show you is some things from the web. For many years, most of the statistics that was done on language was done on a corpus called the Brown corpus. How many of you are familiar with it? Okay, so the Brown corpus was collected in the 70s. It's nothing to do with Brown University. It's a bunch of researchers, one of which, no, it's the other way around. I don't know. Take that back. Brown corpus was collected in the 70s, and at the time it was a revolutionary achievement because it was by far the biggest computer-based corpus that existed until then. I arrived at CMU in '86, and I started working in language in '89, and I sent away for a copy of the Brown corpus. It came back in a magnetic tape. There was no web. Couldn't get it off the web. It had 1 million words, and it was considered a balanced corpus in that it had many different genres. It had a little bit of legal proceedings, and a little bit of fiction, a little bit of newspaper. I forget what else. There was a whole bunch, like 6 or 7 different genres that were considered representative of written English. A lot of statistics were done on that. Of course, since then, a few decades have passed. All the genres changed. So things have changed by more than a little bit. I want to show you some examples. For many years, it was a mantra in the field that the most common letters in the English alphabet are eta, oin, shriddle, This is like an easy way to, easy mnemonic, easy way to remember them. Eta, oin, shriddle. The most common letter is E, followed by T, followed by A, O, I, N, and so forth. That was true, but apparently it's not true anymore. So, okay, so here's the article. English letter frequency counts revisited, or eta oin shrill dessous. So the eta oin part didn't change, but starting with this letter, I'm sorry, starting with H. No, starting right here. H should have been here, and it got switched. Let me find letter frequencies. Here are the letter frequencies. These are based on Google Books. So they're based on a much, much, much larger corpus. But more important than the size of the corpus, so it's a corpus of, what, 3.5 trillion words? Letters, I'm sorry, 3.5 trillion letters. What's more important than the size of the corpus is that the language has changed. Because for something as common as letters, after you get to 100 million size corpus, it should not change much, right? It should not change at all. The fact that it did change over the years, to me, means that it was a change in the language, not that the estimation got better. The estimation got better, but was not the main reason. So look at the R and S. R and H, there's a big difference here. And if you think about the Schroeder Owen, so this became SRH, the C, sorry? So L and D swap to, and then CU. L and D, and then C and U. So these got swapped, and these got swapped. This is quite remarkable to me that H and R got swapped, because there's a big difference between them. So my conclusion is that probably they were not well estimated in the Brown corpus.
U has moved down a rank. Could that be to do with the relative representations of British versus American English in the two corpora?
That sounds like a reasonable hypothesis to me. British versus American English, another possibility for your homework. Thank you. All right, as long as we're looking at a school website, let's look at word distributions. So the rules supreme, but it's now 7%. When I grew up, it was 5%. Again, I think it's a change of genre of what Brown is based on and what the other things were based on. I'll tell you a story. I don't have time for a story. I'll tell you the story some other time. Okay, I'll let you go. You have a fun, open-ended assignment on the web.